Hello guys, good morning. Welcome sa subject natin, numerical methods. This is our fourth contact session, and for this session, we will be discussing about numerical differentiation. Okay, so before we ended our lecture last time, before you had your midterm examination, discuss na natin yung about sa root finding, no? Sa paghanap ng values of x by using yung mga methods na discuss natin. Okay? So now we will now go further dun sa discussion natin. I will be focusing dun sa natawag natin numerical differentiation. Okay? So, based from your previous mathematics, pag may given tayong function, meron tayong mga formulas na pwedeng gamitin para ma-derive natin yung function analytically, no? Pero there are some cases na halimbawa naka-plot sa isang um, axis yung mismong curve mo, then kapag yung curve mo is hindi siya directly ma-define by a linear function or any function na mas familiar tayo, mahirapan tayo kung paano natin siya derive, no? So, by using yung method na discuss natin, we can now be able to get the derivative of that function using yung mga methods na i-discuss natin. Okay? So, at the end of the session, hopefully these are the things that you will be um, faced with, or ito yung take home nyo after this lesson. Uh, First one is to introduce yung numerical solution in determining the derivative of a function. Okay? So dahil pag derivative pinag-usapan natin, about first derivative, we are talking about dun sa slope ng curve natin. Okay? So slope meaning yung rise over run ng curve natin, or yung first derivative niya. Okay? Then to show how each numerical differentiation solution is derived, o kung paano siya madaling tandaan, no? Kung paano siya nakuha yung formulang gagamitin. Then lastly is to solve a function using numerical differentiation methods. Okay? So let's start with the introduction. So numerical differentiation, so based from your derivative differential calculus class. Okay? So yung first derivative daw natin is approximately equal dito sa formula na to. Okay? So f of x plus h minus f of x over h. Okay? So for linear functions, generally itong equation na to is true, or nagbibigay siya ng uh, exact first derivative ng function. Pero kapag yung function natin is complicated, this particular solution will not give an exact derivative, but will give you a value near your exact value depending dun sa step size natin, ay yung h na tinatawag dyan. Okay? So, in numerical differentiation, we have three different formulas or methods that we can use. So, yung tatawag natin forward difference method, backward difference method, and central difference method. Okay? So, we will now first discuss yung forward difference method, and each method will be discussed on how we can derive each one. Okay? So, let us start with yung forward difference method. Okay? So, sa forward difference method, let's say we have a function. So, yung kulay red, no? So, let's say sabihin natin, tawagin natin yan, i-function y, no? So, any function yan. So, sa forward difference method, ang gusto niyang sabihin, mag-consider tayo ng isang point along the line. Okay? So, tawagin natin yung first point natin as P1. Okay? And then, since forward difference method tayo, sabihin, magko-compare tayo ng another point na mas ahead dun sa initial point natin. Okay? So, let's say sabihin natin ito yung second point na kinukuha natin. Okay? Yan yung P2 natin. Ngayon, para makuha yung, pag kinonsider natin yung curve na to, no? So, pag pinapakuha yung first derivative niyan, ibig sabihin pinapakuha yung slope niyan. So, paano natin makukuha yung slope niyan? Once na meron na tayo nung lines natin, nung point natin, we can connect that 2 points, no? So, kung makikita nyo, meron tayong na-form na line. Okay? Yung line na yon is almost more or less approximately equal dun sa curve natin, no? So depende sa laki ng step o sa laki ng distance ng P1 and P2. Pero in generally speaking, yung um, line na nagko-connect sa P1 and P2 is will give you yung same value nung part na yon. Which is dito sa line natin, sa curve natin, yung blue line na yon is tinatawag natin slope. Okay? So, in your previous mathematics, anong pinaka-basic definition ng slope? Okay? So, sabi natin si slope is defined as, pinakasimple, rise over run. Okay? Ng coordinate points natin, no? Nung mismong points natin. So, ano ba yung points na tinutukoy natin? So, si P1 and P2, kailangan i-project natin dun sa x and y axis natin. Okay? So, si P1, pag pinroject natin, ito yung intersection niya dun sa x-coordinate natin. Si P2, ito yung coordinate niya. Okay? So, si P1, tawagin natin xi na lang, no? As yun yung kumbaga initial natin na point. Then si P2, tawagin natin xi plus delta x. Okay. So, bakit delta x? Meaning, si delta x is yung distance ni P1 kay P2. Kaya, para makapunta tayo dun sa point ni P2, mag-a-add tayo ng delta x na width, no? Na step size, no? Tawag natin sa delta x ay step size. Okay? And then, we try to project din yung ating points sa y natin. Okay? So, pag nag-intersect siya dito, ibig sabihin niya, ito yung function kapag sinubstitute natin yung value ni xi. Then, yung isang point, yung P2 natin, yung pag pinoject natin is yung f xi plus delta x natin. So meaning yung value ng function o yung value ng y kapag sinubstitute natin yung x coordinate natin. Basically yun yan. Okay? So kapag zoom natin dito sa portion na to, okay? So ito yung mappo-form natin na okay? So ito yung rise natin, ito yung run. Okay? So substitute lang natin yan dito sa formula natin ng slope. Okay? So in differential calculus, the slope ay equals dun sa first derivative natin. Okay? First derivative ng function or f prime x na lang. No? Okay? Tapos, ano yung rise? So yung rise natin is yung difference nung coordinate ng y point ng P2 minus yung P1 natin. Okay? So, ibig sabihin, fxi plus delta x minus yung fxi all over yung run natin. So, yung run natin is ano yung value ng run? So, parehas siya nung delta x natin. So, basically, delta x yung value nito. Okay? So, yung formula na tinatawag natin ito, okay? Ito yung formula para sa forward difference method. Okay? So, ito na mismo yung formula ang gagamitin natin to identify yung value ng first derivative using forward difference method. Okay? So, later i-apply natin yan sa example. Pero now, we will now first go dun sa second method natin. Tinatawag naman natin na backward difference method. Okay? So, by the name suggests, since backward naman siya, ibig sabihin from our initial point na P1, kanina, no? Ngayon, yung point na consider natin ngayon is doon naman sa left side niya, no? So, kanina moving forward tayo para kaya nag-forward tayo. Ngayon, moving backwards tayo. Okay? Then, again, pag pinoject natin sa x-axis, so we have dito xi, And dito yung magiging xi na value ng x natin is xi minus delta x, no? So same pa din. Ito pa din yung step size natin. Okay? Then pag tinignan natin yung projection niya dito sa y-axis, so we have dito f xi minus delta x and dito is f xi. Okay? So same procedure, meron tayong connecting line dito. Then kukunin natin yung slope niya by rise over run. Okay, so slope is equals to rise over run. So substitute natin f prime x, meaning first derivative slope is the same. Okay, so ano ngayon yung rise natin? So yung rise natin ngayon dito is from P1 minus P2. So yung y coordinate ng P1 minus y coordinate ng P2. Okay, so we have fxi minus fxi minus delta x all over yung run natin na parallel pa din siya dun sa distance natin ng xi tsaka yung ng P2 in x coordinate, so delta x. Okay? So, ibig sabihin, itong formula na to is our backward difference method formula. Okay? So, yan yung para sa second formula natin, method natin. Okay? Then last, we have yung tatawag natin central difference method. Ngayon, kay central difference method, ang consideration natin is tatlong point naman, no? So, from point 1, consider niya yung forward niya, tapos consider din niya yung backward niya. Okay? So, para yung mapo-form niyang line, pag pinag-connect-connect yung tatlo, okay, is more or less mag-fit dun sa curve natin. So, basically, dito sa drawing natin, hindi siya exactly nag-fit na saktong-sakto, pero which is nag-approximate naman tayo. So, yung exaggeration lang nung drawing natin, kung let's say, sabihin natin, ito yung P2, ito yung P3, no? So, straight line lang yung maano natin doon. Okay? So, parang in-exaggerate lang natin dito. Okay? Then ngayon, pro-project natin sa x-axis ulit. So, ngayon ito yung xi natin. So, kung equal yung distance natin, yung step size natin, sabihin itong point na to is xi plus delta x. And itong point na to is xi minus delta x. Okay? And pag pinroject natin sa y-axis, so we have xxi minus delta x. So dito is fxi plus delta x. Okay? So pag kinuha natin yung slope, ang consideration natin ulit is rise over run. Okay? Rise over run. So slope natin, first derivative ng function. Okay? So ito is yfx, yung red line natin. Equals sa rise. So ibig sabihin yung 0.2 minus 0.3 na y coordinate. So xi plus delta x minus fxi minus delta x all over. Ano yung magiging run natin ngayon? So yung 0.3 magta-travel papunta kay 0.2 ng ilang beses na delta x? Dalawa. Okay? So kaya ang nasa solution natin 2 delta x. Okay? So ito na yung magiging general definition ng central difference method. And yan na yung tatlong formulas natin to use or to approximate yung mga derivative ng functions natin. Okay? So in some cases, in some books, yung delta x is represented by h, no? Pero isa lang meaning niya, no? Lagi siyang step size. Okay? There are other methods kung paano i-derive tong mga formulas na to, especially using Taylor series, no? Pero I opted not to discuss yung sa Taylor series kasi baka mas maguluhan kayo. At least by using this derivation, mas madali yung makuha yung equations ng tatlo. Okay? Na mamaya makikita natin iba-iba yung magiging values ng tatlo. Bakit? Kasi in the original uh, derivation using Taylor series, meron tayong inaalis na portion. 'Di ba sa Taylor series may nakikita tayong yung function plus yung first derivative plus second, third derivative. If you would recall yung sa Taylor series na research nyo, ang ginagawa natin, tinothrow down natin lahat ng second derivative pataas na function. So meaning, pag inalis natin o tinrow down o hindi natin kinonsider yun, meron tayong mga numbers na hindi sinasama doon sa approximation natin. Yun yung error na nangyayari kaya hindi equal yung value ng forward, backward, and central difference. Okay? So, ang tawag dun sa error nyo yun, truncation error. Okay? So, para alam nyo kung bakit nagkameron ng different value yung tatlong method na to. Pero mamaya makikita natin kung alin doon sa tatlong method yung mag-a-arrive sa mas malapit na approximate value. Okay? So let us use these methods in a example. So we have our first example. So our first example, wait, naghang yung ating ano. Okay. For a while, i-share ko lang. Okay. So we have our first example. Example 1, find f prime of 3 using the forward, backward, and central difference method of the function f of x is equals to x cubed plus 4x squared plus x plus 1 with the given step size of h is equals to 0.2. Okay? So, pinapanap sa atin is yung value ng first derivative taking yung value ng x natin is 3. Okay? So, we have gamitin daw natin sa forward, backward, tsaka central difference. Okay? So, yung step size, ibig sabihin, equivalent yan dun sa delta x natin. Okay? So, sa first example, sabi niya, forward difference method yung gagamitin natin. Okay? Yung derived formula natin, f prime x is equals sa, ano yung value ng forward difference method natin? So, we can go back dun sa derive natin. So, xi plus delta x minus f sub x sub I over delta x. Okay? So, sub I plus delta x minus fx sub I all over delta x. Okay? So, yung x sub I na tinatawag dito sa solution na to is pertaining dun sa hinahanap nating value ng nung derivative, no? So dito f prime 3, no? So ibig sabihin si 3 dito yung initial point natin. Okay? So ibig sabihin sa xi natin is si 3. Okay? So sa formula natin kailangan natin ng xi plus delta x. So meaning yung 3 natin dadagdagan natin ng 0.2. So ibig sabihin 3.2. Okay? And pag sinubstitute natin sa formula, we have xi plus delta x is 3.2 minus f of 3 all over delta x natin is 0.2. Okay? So, kailangan natin ngayon hanapin si value ng function, yung function natin, na ang sasubstitute nating value is 3.2. Tapos, kailangan din natin ng f of nung function natin na sasubstitute natin ay 3. Okay? So, mula dito, so, f of x is equals to x cubed plus 4x squared plus x plus 1. So, substitute natin yung 3.2. So, equals siya sa 3.2 cube plus 4, 3.2 squared plus 3.2 plus 1. Okay? So, yung value ng f 3.2, pag kinuha natin sa calcu, is x cubed plus 4x squared plus x plus 1. So, we have a value of 77.928. Okay? Then, ngayon, yung isa pang given na kailangan natin, f is 3 naman yung sa-substitute natin. So, 3 cubed plus 4, 3 squared plus 3 plus 1. So, yung makukuha nating value is 67. Okay? Once nakuha natin yung value na yon, isa-substitute lang natin siya dun sa given equation natin. Okay? So, 77.928 minus 67 all over 0.2. F prime of 3. Okay? So, equals din sa 77.928 minus 67. Then, divide natin ng 0.2. Answer natin is 54.64. Ito yung approximate value natin. Pero ano ba yung true value natin? O yung exact value ng mismong problem natin. So, para makuha yun, we need to, pag yung sa differential equation na method, kunin natin yung first derivative ng function natin. Okay? Okay? So, yung first derivative niyan is 3x squared plus 8x plus 1. Okay? Then, substitute doon natin yung value ni 3 equals sa 3 squared plus 8 times 3 plus 1 equals yan sa 52. Okay? So, kung compare natin, yung nakuha natin using FD is 54.64. Then, ito is yung ating exact value. Ano yung relative true error natin? Okay? Relative true error natin is true value minus approximate value all over true value times 100. So, substitute lang natin. So, we have 52 minus 54.64 over 52 times 100. Yung relative true error natin is 5.08%, which is malaki, no? Kung i-consider natin, kung halimbawa pinakuha sa atin is dapat yung specified error natin halimbawa is at least 0.1% lang. Okay? So, para ma-minimize yung error natin, ang gagawin kapag sa gantong differentiation is i-repeat mo yung process pero gagawin mo doon sa step size mo, i-half mo siya. So, from h is equals to 0.2, gamitin mo yung kalahati nun as your second iteration. So, h is equals to 0.1 naman yung gagamitin mo. Then, once nakuha mo yun, kunin mo ulit, makukuha ulit approximate value. Then, kunin mo yung approximate true value mo. Then, i-compare mo dun sa specified true value mo na i sub s. No? Hanggat hindi na satisfy, i-half mo lang i-half yung step size mo. Okay? So, yan yung sa forward difference natin. Ngayon, kasunod nating method is yung backward difference method naman tayo. Sa backward difference method, ang formula natin for f prime x is equals to f ng x sub I minus f ng x sub I minus delta x all over delta x. Okay? Then again, yung x sub I natin is 3. Then x sub I minus delta x naman yung kailangan natin. So 3 minus 0.2. So we have 2.8. So dito ang kailangan natin is f prime of 3 equals sa f of 3 minus f of 2.8 all over 0.2. Okay? So kailangan identify ulit natin muna yung value. F of 3 is calculated already earlier. Nung nakuha nating value is 67, no? Okay? Then next is yung f 2.8. So we have 2.8 cubed plus 4, 2.8 squared plus 2.8 plus 1. So ilan yan? So 2.8 cubed plus 4, 2.8 squared plus 2.8 plus 1. So we have 57.112. Then we substitute that dun sa given natin, no? So substitute natin f of 3 is 67 minus 57.112 all over 0.2. So makukuha natin yung value ng f prime 3 is 49.44. Okay. Ito yung approximate value natin using backward difference. Okay? So pag kinuha natin ngayon yung relative error natin, true error, equals yan sa value natin kanina is calculated 52 yung exact value natin. So 52 minus 49.44 all over 52 times 100. So ang relative error natin is so we have 4.923%. Okay? So a little high lower dun sa forward difference pero hindi pa din na masasatisfy yung halimbawa sinet natin na specified criteria natin na 0.1%. Okay? Again, to achieve yung criteria natin, all you have to do is to minimize yung step size natin or i-halve natin yung step size. So from 0.2, uulitin yung iteration, magiging siyang 0.1. Then kapag halimbawa hindi pa din masatisfy yung 0.1%, iterate ulit natin, gagamitin naman natin 0.005. 0.05 pala. Okay? Then ulitin ulit. Then pag hindi pa din okay, 0.025, then and so on and so forth. No? Okay? So yan yung para sa backward difference natin. Okay? Then last is pinapagamit sa atin is yung central difference method, no? Si central difference method, ang formula niya is f of x plus xi plus delta x minus f of x sub I minus delta x all over delta x2. No? May 2 dun sa denominator natin. So again, x sub I natin is 3. X sub I plus delta x natin is 3.2. X sub I minus delta x natin is 2.8. Okay? So kailangan natin dito is f prime of 3 is equals to f of 3.2 minus f of 2.8 divided by 2 times 0.2. Okay? So, fortunately, calculated na natin yan. Yung f prime of 2 tsaka f prime of 2.8. Kunin natin sa previous problem. So, 57.112 to. Then, yung 3.2 is 77.928. Okay? So, lagay natin 77.928 minus 57.112 all over 0.4. So, makukuha natin value is 52.04. Okay? So, ito yung approximate value using central difference. Okay? Kunin natin yung relative error, true error. So, yung true value natin is 52 minus 52.04 all over 52 times 100. So, relative true error natin will be 0.077%. Okay? Which is acceptable based dun sa bawas set natin criteria na 0.1%. Okay? So meaning mas madaling mag-converge si central difference method or mas madali natin makuha yung first derivative ng function natin when using central difference method kasi kino-consider niya yung forward and backward natin. Okay? So, if ever hindi naging equal sa 0.1 o less than 0.1% yung relative true error natin, again, all you have to do is to um, repeat the iteration and i-half nyo lang yung step size natin. So, for this case, from 0.2, gagawin natin 0.1, 1, 0.05, 0.025, then 0.0125, and so on. No? Okay? So, yun. Ganun lang kasimple yung pag-differentiate using numerical methods. No? Okay. So, ito yung first example natin using a rather much simpler function, no? Paano kung medyo complicated yung function natin? Okay? So, this is an application in physics or engineering mechanics, no? Okay? So, the velocity of a rocket is given by the formula for velocity is equals to 2,000 times natural logarithm of 14 times 10 to the fourth over 14 times 10 to the fourth minus 2,100 times t minus 9.8 of t, wherein this function uh, is valid for range of 0 to 30 seconds. Okay? Where yung v natin is given as meter per second and yung t natin is given in seconds. Okay? So yung question natin, use forward difference approximation of the first derivative nung v sub t natin, v of t, to calculate the acceleration given na t is equal to 16 seconds tapos yung step size natin is 2 seconds. Okay? Then find down natin yung exact value. Then hanapin natin yung absolute relative error ng given problem. Okay. So, pinapagamit is forward difference. So forward difference, okay, so forward difference, again, ang value ng first derivative natin is equals to f x sub I plus delta x minus f x sub I all over delta x. Okay? So dito ang step size natin is identified as 2 seconds. No? Ito yung delta x natin, no problem. And then pinapahanap is yung acceleration. So sa physics, kapag given ng function halimbawa ng velocity, no? Pag kinuha mo yung derivative niyan, equals yan dun sa pag kinuha mo yung derivative niyan, equals yan dun sa acceleration ng function. Okay? Similarly, kapag halimbawa given sa atin yung distance, yung function distance, pag kinuha mo yung first derivative ng function na distance, yung first derivative niya, equals yun sa velocity function. Okay? And pag kinuha natin yung second derivative, equals yan, or equivalent sa first derivative ng velocity, equals yan dun sa acceleration ng function. Okay? Kaya dito, nung kinuha yung first derivative ng velocity function, makukuha mo is yung acceleration. So meaning, pag kinuha natin yung first derivative, A sub t yung makukuha nating value. Okay? So, let's proceed. So, yung formula natin is V sub t is equals to, okay, so 2,000 natural logarithm of 14 times 10 to the fourth, lower 14 times 10 to the fourth minus 2100 t minus 9.8t. Okay? Again, yung formula natin, forward difference is fx sub I plus delta x minus fx sub I over delta x. Okay? So yung x sub I natin is given sa problem as our first t, value ng t ay 16 seconds, no? And then, yung delta x daw natin, step size natin is 2 seconds. So, ang xi plus delta x natin will be 18. Okay? So, ibig sabihin, pag sinubstitute natin to, f prime of x sub I, yung sa 16, yung value ng first derivative, will be equal sa f nung 18 minus f times 16. F16. As step size natin is 2 seconds. So, kailangan lang natin kunin yung value ng F18, no? Meaning, sa substitute natin yung 18 dun sa formula natin ng velocity. Okay? So, 2,000 ln 14 times 10 to the fourth over 14 times 10 to the fourth minus 2,100 times 18 minus 9.8 times 18. Okay? Calculate lang natin. 2,000 ln of 14 raised to 4, 21 times 18 minus 9.8 times 18. Okay? Calculated value of F18 is equals to 453.021. Okay? Then next is for F16. So same din, sa substitute mo lang doon. Pero imbis na 18 yung input mo, 16 yung ilalagay natin. So we have a value of 392.074. Okay? And substitute natin, we have 453.021 minus 392.074 lower 2. So f prime of 16 or yung acceleration natin given 16 seconds is 453.021 minus 392.074 divided by 2 equals yun sa 30.4735 meter per second squared. Okay? So, yan daw yung value niya using forward difference method. Okay? So, ito yung value daw natin. Ito yung answer for letter A. Okay? Now, we try yung sa letter B, which is kunin daw natin yung exact value niya. So, yung exact value natin, makukuha natin kapag kinuha natin yung derivative ng given function natin. So, paano i-derive tong ganitong problem, no? Okay? So, yung given function natin is, kung isa-simplify, is meron tayong constant, no? Tapos meron tayong ln, tapos merong function sa loob, no? So, let's say sabihin natin u minus a constant tapos t. Okay? Para makuha yung derivative niyan, kailangan mo lang c times derivative ng ln is 1 over u du minus yung kasunod c times dt. Okay? So, ibig sabihin, kailangan lang natin kunin yung derivative ng natural logarithm tsaka derivative ng t. Okay? So, focus muna tayo sa natural logarithm. Minus 2,100t. Represent natin na yung nasa loob ng ln is u. Okay? So, ibig sabihin, magiging derivative natin is 1 over u times du. Okay? So kung 1 over u yung first term, equals to sa 14 times 10 4 minus 2,100t all over 14 times 10 to the 4. So, ibig sabihin, kinuha lang natin yung reciprocal nung nasa loob. Okay? Then, yung derivative ng u, okay, dito natin. So, dito natin ilagay. So, yung u natin is equal sa 14 times 10 to the 4 all over 14 times 10, 4 minus 2, 1. Okay? So, yung du niyan is using derivative ng quotient. Okay? So, kunin natin to as v, kunin natin to as w. Yung solution natin will be w dv minus dw all over w squared. Okay? So, w is 14 times 10 to the 4 minus 2,100 t. Ang dv natin is constant, so 0 to. Minus yung v natin, 14 to the 4th times derivative ng w is negative 2,100. Okay? Lower, squared lang natin yung minus 2,100t squared. Okay? So, yung du natin, pag sinimplify, will be um, okay? So, that will be positive, no? 14 times 10 to the 4 times 2,100 all over 14 times 10 to the 4 minus 2,100t squared. Okay. So, yan yung derivative natin doon. Then, pag sinimplify natin, um, okay. So, didistribute lang naman natin. So, ito ay walang negative to. Okay. So, magigitong 1 minus 2,100 divide 14. So, 3,200t, no? And this will be 14, 4 times 2, 100. So, 2.94, 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8 all over 14 times 10 to the 4 minus 2,100t squared. Okay. Then, i-plug in na natin to dun sa dito, no? So, yung magiging derivative natin ngayon will be equal sa, kung ano yung constant, 2,000, excuse me, plus 1 minus 3 over 200t multiplied by 2.94 times 10 to the 8 all over 14 times 10, 14 times 10 to the 4 minus 2,100t squared. Okay? Minus 9.8 lang. No? Kasi yung t magiging 1. Okay? So, yan yung derivative natin. So, equals to sa at, no? A of t. So, substitute lang natin yung value na 16. So, 2,000, 1 minus 3 over 2,000, 200 times 16. So, 2.94 times 10 to the 8 all over 14 times 10 to the 4 minus 2,100 times 16 squared minus 9.8. Value natin, exact value is, excuse me, over 200 times 2.94 to the 8 all over 14 to 100 times 16, then it's squared minus 9.8. So we have a value of 29.674 meter per second squared. Okay, So ito yung exact value natin. Okay? Yan yung answer natin sa letter B. Ngayon sa letter C, pinapahanap ngayon yung error. No? Sa letter C is yung relative true error natin. So, sa relative true error natin, kailangan natin yung approximate value tsaka yung true value. Again, true value is calculated as 29.674 meter per second squared. And yung approximate value natin based from A ay 30.4735. Okay? So, will be 29.674 minus 30.4735 all over 29.674 times 100 4735 all over 29.674 then times 100. May error tayo na 2.694%. Okay? So kung criteria natin halimbawa is 0.1%, our relative true error is malaki pa, no? So para makuha natin yung mas mababang value niya, kailangan yung step size natin, no? So ito yung values natin kanina. Yung step size natin nung una, 2 second, ang error natin is 694. So para mas lumiit siya, i-half natin, gagawin natin ay 1 second naman. Then kapag in-iterate nyo yun, yung makukuha mong value ngayon ng pag inulit mo siya, okay, will be sana yan. Okay. Yan, kung halimbawa ay itutuloy natin, no? Pag 1 second, ang estimated true error nyong makukuha is 1.329. Kapag naging 0.5 seconds, magiging siyang 0.6597. Pag naging 0.25, magiging siyang 0.328. No? Then kapag hinaf ulit natin, 125, magiging 0.163. Then kapag hinaf pa natin yon, pag step size natin is 0.0625, ang error natin is 0.810. Okay? So, ibig sabihin sa step size na to, dito pa lang natin ma-accept yung sa criteria natin. Okay? So, after ilang iteration pa siya. So, 1, 2, 3, 4, 5. Yung fifth iteration natin, doon mo pala makukuha yung almost exact value or maliit na error na value para ma-estimate mo yung pinakamalapit na answer. No? Okay? So, for your exercise na lang, you may try to calculate yung value niya for backward difference. Then, i-check nyo kung ilang iterations bago maging 0.1% or less than 0.1% yung relative true error. And same with central difference. No? So, kung ilan lahat yung ma-calculate yung error, iterations, pa-indicate na lang. So, that will serve as your laboratory, no, for this matter or this topic. Okay? So, I'll be posting yung activity in the Neo LMS. Then, you can attach a copy of your yung table na lang, no? So, pwede kayong gumawa ng table ulit sa Excel. Then, kung paano nangyari yung iteration na values natin. Okay? So, if you have any question, you may reach me sa Messenger, no? Or sa Neo LMS for clarification. And kung wala naman, this ends our discussion and our topic for today. Okay? So, thank you so much for attending our class and see you guys again for the next contact session, which will be on the 24th. Okay? 2 weeks from now. Okay? So, good luck sa defend ng thesis this week. And Stay safe po. Okay? Thank you po.